Hello, good morning, thinkers. Mrs. Post here. Today is Monday, April 13th, and I hope you all had a good long weekend spending time with your family. Today we are going to work on problem solving. Well, this whole week we're going to actually work on problem solving. If you have your book, we're actually going to work on chapter 10, which is identifying features of a model. And we're going to start with this. So if you have your book, you're welcome to use it. I just tried to get some pictures and upload them here. I'm just going to go through one example today real quick, and then you guys have one I want you guys to try together, and I'll tell you how I want you guys to try to solve it. So if you guys will, this is just a couple little bits of notes for you guys. You can save this, and you can save it in a file on your computer or your phone or wherever you're doing your virtual schoolwork, or you're welcome to print it out. But there's some color on this, so it might use some ink. So I would be hesitant to print this out, but it's a Word document, so you should be able to edit that if necessary. So we're going to start with this lesson 10.1, and I'm just going to go over it with you guys. I'm just going to model this for you. It's not really a lot of guided notes because it's just problem solving. So we're going to talk about graphing. So the reason why we're doing this chapter is about identifying features of a model, and today's model is going to be of a graph. And a lot of times you guys have used, graphs before. Many times, particularly if you look right here in the text, it says we need to know some information about the graph so we can get information from the data so you can figure out whatever you need to know. So a couple of things I'm going to see if I can write on here. So you need to know what the x-axis represents, what the y-axis represents, what it stands for, what it represents, and it talks about the word gradient of the line. And so I don't know if you guys are sure what that means, but the gradient actually means like the slope of the line, so how steep it is. So what else does it say? You may also need to know what it means if the points on the line where the lines meet, like if they intersect, if that has a meaning, and just if the lines cross, what that might mean. So just some things to look for whenever you guys are looking at graphs. So this example right here comes from your text. And so it just says that you have a graph right here, and it shows two journeys carried out by remote control cars. One car is red. You can see how it goes kind of just in a constant, not constant, but in a linear fashion. The gradient here is going to be, the slope is going to be constant. So one car is red and the other is blue. So it says right here, your horizontal axis shows the time. So you can see right here, your horizontal axis, you guys remember that's always your x, and it's going to represent time. And the vertical axis is your y. That's this one over here. And it says that one is going to represent the distance away from a place. So how far it is away from wherever the starting location is. Is it from a store? Is it from a house? Whatever it's from, a mailbox. And so the cars do travel in a straight line. So you have two questions. You have question 1 and you have question 2. Number 1 asks, what can you tell about the journey of the two cars? So a couple of things I want you guys to be thinking about is that you can see that the red car is kind of going in the same kind of fashion, whereas the blue one is coming from a different direction, and it looks like it is going to, there's a certain point with this blue car where it's just going to kind of stop, but you can see that they do kind of, at one point they are kind of the same distance away from a particular point. It's also saying, number 2, what do the gradients of the two lines tell us? So remember, when we're talking about the word gradient, remember we're talking about slope. Okay, so for number 1, a couple of things I would write down. What can you tell about the journey of the two cars? Well, hopefully you guys will see a couple of different things, kind of like what we just talked about. So let's look at maybe the red line. Hopefully you guys can see that right here, right where they cross, this is about 4 seconds. So you could say something at 4 seconds. This is what I would write down. At 4 seconds, both cars are the same distance from the measuring point or from the measuring point. Okay, so if you look at the distance, it says displacement, which really means the distance. If you look right here, like that's also at about what, 4 as well. So at 4 seconds, they're the same distance from wherever they started. So, okay, so there you go. And then I think it asks us one more thing. What else do you notice here? Because I'll make a little note, that's right where they cross. So they do have one point in common right there. And there's something else I want you guys to notice at about right here. This is at about 6 seconds. So here's one point to make. Here's another point to make. At 6 seconds, so it's kind of like you guys are just making observations here. At 6 seconds, the blue car stops. So if you'll notice at this point, as time is going, his distance isn't changing. So the distance isn't changing. So it's just stopping. He's not moving any way further away from where the car started. He's just at that distance is, I think it looks like it's at maybe 1, 2. So at 6 seconds, the blue car stops. And it's really right here at this particular meters away. I guess it's 2 meters away from where he started. So well, he started up here, 5, 6, 7, 8. Okay, so hopefully you guys are noticing that. So it's a 2, I'm so sorry, at 6 seconds, he's going to stop right there. Okay, so now we're going to talk about number 2. And it's asking you about the gradient. And this is really something that you guys should be using. As an algebra teacher, I want you guys to use algebra if possible, because it's one way to get some numerical information. And it's a pretty quick way to do so. So let me go ahead and see if I can change my pen a little bit. So let's take a look at number 2. So it's asking us for the gradient or the slope, like we kind of talked about. And you might remember how to calculate the slope. You might actually remember how to do so. So if it's asking us for the slope of the 2 lines, you guys might remember how when we talk about the change in y over the change in x, or maybe you remember it as the rise over the run, how you get 2 different points and you can calculate the distance or the difference between them, and you guys can get the gradient, or in this case, the slope. You can figure out how steep the line is. How is one variable is changing? How is the other changing? So I'm going to do that. I actually am going to start with, if you guys want to go ahead and try maybe I think I started with the red line. So with the red line, what I did was I went ahead and I just found a couple points. Like I know there's a point right here, and it looks like that point is going to be 0, 2. And then I believe I used, you can use any point you want. I actually used a ruler, and I went right over here to see what happens at 1 second, which is about right here. So that point right there was about 1 comma, I believe it was 2.5. It's about 2.5. So I went ahead and found the difference in those, and I was able to find the slope. Hopefully you guys remember how to do that. So if you remember how to calculate the difference in your y values and the difference in your x values, you guys can do that. So hopefully you guys remember, maybe this is your x1, this is your y1, this is your second point, so it's your x2 and your y2. So I know some of you guys are in geometry and you still use this, and also from algebra and algebra 1 you guys use this. So if we're talking about the red line, you can go ahead and find the difference in the y's. So we usually do, you guys might remember, y2 subtract y1, x2 subtract x1. So you can do the same thing here. Okay, so you can go ahead and calculate your y2, which is 2.5, minus your y1, which is 2. And then you can also subtract your x2, which is 1, and your x1, which is 0. So 2.5 minus 2 is just going to give you 1/2. And you can look at it as 0.5, and then your denominator is just 1. So if you kind of think about it, your slope or your gradient in this case is 1/2. But remember, your y represented your distance, and your x represented time. So one way to kind of think through it in words is that for every second, your distance is changing 1/2. In this case, it's meters. So 1/2 of a meter. So as each second goes by, your distance is changing 1/2 a meter. That's the gradient, or that's the slope of the red line. And you can do the same thing with the blue. So I might go ahead and just change my color just so you guys can kind of see it a little bit different. I might change it over here to black. Okay, let's do the same thing with the blue line. And you can just pick 2 points again and try the same thing. So I can actually pick this point right here, which it looks like that's going to be 0.8. Usually try to pick the y-intercept if possible. And then you guys can also pick that 1 second mark right here, which looks like it's going to be 1 and 7. So you can use those 2 points right here. So you can do, this could be your, let's see, your x1, y1, and this could be your x2, y2, and you can go ahead and subtract them as well. So once again, you can calculate your change in y over your change in x, and this could be for your blue line. All right, so the changes in your y are y2 minus y1, which it looks like your y2 is going to be 7, your y1 is going to be 8, and your x2 is 1, and your x1 is 0. So that's going to give you a -1 over 1. Okay, and that's okay. So a -1 over 1, remember the top is telling us the distance, and the denominator is telling us the time. So you can kind of think about it again in words. As every second goes by, there is a change in distance, which would be in this case a meter. And so in this case, the negative right here is just going to represent an opposite distance, opposite direction. Okay, so that's kind of how you can kind of go ahead and tell us about the gradient. So it looks like you can tell that in this particular case, the red one was moving 1/2 a meter per every second, and then this other one, this blue line, is moving a whole meter per every second. So you can tell which one is a little bit more steep than the other. That's kind of what I wanted you guys to be thinking about here when they're talking about the how the difference with the lines. Okay, so I just wanted to kind of review slope and how you can kind of do that to get some information. So that's one way to do it algebraically. All right, you guys, so what I want you guys to do today, and this is all I wanted to go over with you guys, just a review on slope and how you can use algebra to help you with that. Let me see if I can find your assignment for today. I can. Here it is. All right, so this is the image you guys have, and you just have one question, and it asks you, what do the graph and images tell us about trends in the use of smartphones in the USA? We don't have any specific numbers in here. We just have years. And then we have percentages. If you want to estimate where these lines are and try to calculate the gradients, you can. You're welcome to try that, but you're also welcome to just figure out the trends. Like, what are you noticing about usage with smartphones, tablets, computers, and just information that you can gather from the graph in regards to increasing usage of a particular device or decreasing usage of a particular device, okay? You don't have to calculate this algebraically unless you want to. That's completely up to you. Does not need to be algebraically, unless you guys can. That would be kind of cool. I want to show you real quick that in your teams, I opened up a new room, a new channel, and it's called Problem Solvers. So you guys are welcome to start talking to each other for this particular activity, which is the 10.1. So I'm going to write here, problem solvers can work together to solve activity 10.1 in this channel. In this channel, I guess I'll just put that. Okay, so you guys are welcome to do that, and that's what I want you guys to do for today. And then once you guys finalize on what you believe the solution is or what information you guys can get, you're welcome to write it on here and then turn it in from here. So you can turn it in just writing on this document. You can just do it on a sheet of notebook paper and just take a picture and send that in. That's fine, but you're welcome to collaborate and work together as you would normally do in class, because this is not a mastery grade, but it is practice, because you will have a mastery grade this week and one next week too. Okay. So go ahead and work on this together in the channel, the problem solving channel, and then send it in to me whenever you guys are done. And like I say, you don't have to do it algebraically unless you want to. And if you can figure out a way, that'd be kind of cool to see. All right, you guys have a great day, and be sure to visit me from 10 to 12 and 2 to 4 today if you have any questions. All right, have a fabulous day.